So let us start with our basic concepts. How do we calculate distance within analytical geometry? If we want to calculate the distance between 2 points, we are going to make use of our distance formula. Now, our distance formula is the square root of x minus x1 squared plus y2 minus y1 all squared. That is our distance formula. You can find this formula at the back of your question paper should your teacher wish to give it to you. And if you don't want to memorize it, if your teacher is not willing to provide you with the formula sheet, then you would have to memorize it. So let's look at our first example. We've got example 1, calculate AB and CD. So AB refers to the distance from point A to point B, and CD refers to the distance from C to D. So let's start with calculating AB. So we know coordinates of A are given as 2 and 3. Our coordinates of B are given as 5 and 7. Now, we need to decide which values are going to be denoted by x1, x2, and which values are going to be denoted by y2, y1. So I'm going to have A denoted by x1, y1. I'll have B denoted by x2, y2. You cannot have x1, y2, or x2, y1. That doesn't work. 1 has to go with 1 and 2 has to go with 2, meaning x1 gets y1, x2 gets y2. Okay, so please be careful with that. From here, we can put in our distance formula. Our distance formula is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now, the distance that we are calculating is the distance from point A until point B, that is AB. So in place of D, we can substitute AB. Now, our x2 value, we've denoted our x2 value as 5. So we can substitute 5 in place of x2. We bring down our negative sign, and in place of x1, we are going to substitute 2, that is all squared. Now in place of y2, we are going to substitute 7. In place of y1, we are going to substitute 3. And don't forget to complete your square root sign. From here, you can put this entire thing into your calculator. So on your calculator, you'll press your square root button first, open a bracket, 5 minus 2, close the bracket, squared, plus open a bracket, 5 minus 3, close the bracket, and then press equals. You'll end up with 5. Now, because they've not specified a unit of measurement, you can just go with units. If the question specifies a unit of measurement, use the unit that they have specified. So that is how we can now find the distance AB. Let's move on to finding the distance of CD. So we're going to use the exact same procedure. Let's write down the coordinates of C, which are -5 and 6, and D, which is -2 and 1. Now, with calculating the distance CD, be extremely careful because as you can see, there are negative values involved and our formula makes use of a negative sign. So that can be kind of tricky if you don't do it correctly. So let's have a look. I'm going to make my coordinates of C, x1 and y1, my coordinates of D, x2 and y2. Let's put in our distance formula. That is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. From there, we can substitute D as CD, which is then equal to, so my x2 value, that is -2. My x1 value, that is 5. So don't just write minus 5. That is incorrect. You have to bring down the negative from the formula and then substitute the negative 5 from the coordinate of C. So be careful with that. If you just substituted minus 2 minus 5, that is wrong. You have to substitute the negative 5. So you bring down the negative from the formula, open a bracket, put negative 5, then close your bracket. So let us continue. And don't forget, this is squared plus y2, which is 1, minus y1, which is 6, close the bracket, squared. Now, before I put this into my calculator, I want to simplify that x values. So that is going to be minus 2 plus 5 squared, because negative times negative becomes positive. Plus, I'll put 1 minus 6 all squared. From here, I'm now going to put this into my calculator. So I've got negative 2 plus 5, close my bracket, squared, plus, open a bracket, 1 minus 6, close the bracket, squared. Press my equal sign, and that gives me the root of 34. Because I don't have a specified unit of measurement, I'm just going to use units. If you want to, you can also use the decimal value, which is 5.83. That is completely up to you. So you can leave it in a surd form, or you can use the decimal value. So let us move on to the next part. So that was calculating distance. Our next part is to calculate midpoint. Now, midpoint refers to the center point between two coordinates or 2 points. So let's do an example. If we have point A, point B, and point C. If our midpoint is point B, it means that to go from A to B is the same distance to go from B to C. It means that AB is equal to BC. That is the purpose of a midpoint. A midpoint basically means the middle point between two terms. It is the exact halfway point. And the formula that we are going to use to calculate midpoint is M representing midpoint. You don't have to use M. M is just a representation. You can use A, B, C, whatever you want. It's just a representation, but the formula has to be the same. You can't change the formula. So that's going to be x1 plus x2 all over 2, semicolon, y1 plus y2 all over 2, and close the bracket. So in order for you to find the midpoint between 2 points, all you need to do is add the two x values, divide by 2. Add the two y values, and then divide by 2. So let's look at the first example. We need to calculate the coordinates of n and m, whereby n is the midpoint of CD and M is the midpoint of AB. So let us start with M. So the coordinates of A are given as 1 and 3. The coordinates of B are given as 5 and 7. So I'm going to make A my x1 and y1 values, and B my x2 and y2 values. From there, I can put in my formula. So x1 plus x2 all over 2, semicolon, y1 plus y2 all over 2, close the bracket. So I'm going to bring down M. My x1 value is 1. My x2 value is 5, all over 2. My y1 value is 3, and my y2 value is 7. That is all over 2. From here, I can now simplify this on my calculator. Please don't put the entire thing into your calculator. You cannot put a semicolon into your calculator. What you are going to do is only put the x part first, then put the y part. So on your calculator, open a fraction, put 1 plus 5. In your denominator position, put 2. And that is going to give you a value of 3. Now, let's look at the y part. So in your calculator, open a fraction, put 3 plus 7. In your denominator position, put 2. Press the equal to sign, and that gives you 5. Therefore, the midpoint coordinates of M are 3 and 5. Now let us do the exact same thing, but this time we are looking for N, not M. Keep in mind that in this particular case, N represents the midpoint of the line CD. So we'll start by writing out our coordinates. The coordinates of C are -5 and 6. The coordinates of D are -1 and 2. From here we have x1, y1, x2, y2. So our formula, instead of putting M this time, because I'm calculating for N, because they've used N to represent the midpoint, I'm going to use N in my formula instead of using M. So x1 plus x2 all over 2, semicolon, y1 plus y2 all over 2, and close my bracket. So I now need to substitute my values of x1, x2, y1, y2. So I'm going to bring down N, and I'm going to substitute x1 as -5. I'm going to substitute x2 as -1, and that is all over 2. From there, I can substitute my y values, which is y1 as 6 and y2 as 2. And that is all over 2. So I can put this into my calculator. So first we open up our fraction. -5 minus 1. In the denominator position, I put 2. That gives me -3. Now, let's have a look at the y area. So I'm going to have 6 plus 2. In my denominator position, I have 2. That gives me 4. And that is the midpoint coordinate, also midpoint. So in this particular case, we are not finding the coordinates of our midpoint. We are now given the coordinates of our midpoint, and we need to calculate the missing values of the end points. So as you can see, our midpoint coordinate is given as M, which is 5 and 2. Our end points are A and B. Now with A, we've got X missing. With B, we've got Y missing. So we now need to use our midpoint formula to try and find X and Y. So just as we previously did, I'm going to write down my coordinates. So A is X and 1, B is 8 and Y. I'm going to let A be x1 and y1. I'm going to let B be x2 and y2. So from here, I'm going to use my midpoint formula. So my midpoint formula is x1 plus x2 all over 2, y1 plus y2 all over 2. From here, because I already have my midpoint coordinates, I'm not going to now substitute into the midpoint formula. What I'm going to do is I'm going to break up my midpoint formula and separate it into the X and Y parts. So I'm going to have XM, which represents the X value of my midpoint, equals my X part of my midpoint formula. and I'm going to have ym, which represents the y value of my midpoint, equal to my y value of my midpoint formula. So that's all we did. We broke it up. So this is basically what we've done. This x values or x side gets equated to the x value of your midpoint. The y part of the formula gets equated to the y value of your midpoint. That's all you need to do. Now, next, I'm going to now substitute. So I have my x value of my midpoint as 5. I've got x1 as x, and I've got x2 as 8. And that is all over 2. From here, all I now need to do is solve for x. So I'm going to use cross multiplication. So we know that 5 is just over 1. So I'm going to cross multiply over there and cross multiply over there. So I've got 2 times 5, that gives me 10. I've got 1 times x plus 8, which gives me x plus 8. From here, I can move 8 to the other side, making it 10 minus 8 equals x. And I therefore have my value of x as 2, because 10 minus 8 gives me 2. So that's all I needed to do for the x part. We separate the midpoint formula into the x component and the y component. From there, we substitute the x value of our midpoint and the x1, x2 values. In the y area, we equate the y component of our formula to the y value of our midpoint. From there, we substitute. So let us do that. We're going to substitute the y value of our midpoint as 2 equals my y1 value, which is 1, plus my y2 value, which is y, all over 2. From here, we are going to do the exact same thing. We know that 2 is just over 1, so we can cross multiply. So from here, 2 times 2 gives us 4, and 1 times 1 plus y gives us 1 plus y. We can move the 1 over to the other side, making it 4 minus 1 equals y. And that therefore gives us y equals 3. So my x value is 2 and my y value is 3. So before I move on, is there anyone that has any questions relating to what we've just done? Someone that's slightly confused or wants an explanation or something that I need to repeat? You're welcome to speak up now before I move on. Okay, so let us move on. So let's discuss gradient. So gradient is something that is frequently used within math, especially analytical geometry. So we know that our gradient formula is represented by m equals y2 minus y1 over x2 minus x1. So when you are calculating gradient, you're basically calculating the slope of a line, or how steep or how gentle that specific line is. Now we have different types of gradient. We have collinear gradient, we've got parallel gradient, perpendicular gradient, and we've got our normal gradient that we use for that formula. So it is important to be able to understand how to calculate each different type of gradient, as well as the properties of that specific type of gradient. So let's do a quick example. Let's say we've got this line that's got coordinates A, which is 1 and 2, and it's got coordinates B, which is 3 and 8. So if we need to calculate the gradient of that line, what we are now going to do is write out the coordinates so we can decide which is going to be our x1, x2, and which is going to be our y1, y2. So my coordinates of A are 1 and 2. My coordinates of B are 3 and 8. So we've got A, I'm going to make that x1, y1. B, I'm going to make that x2, y2. So from there, I can now substitute. So my y2 value is 8. My y1 value is 2. My x2 value is 3, and my y1 value is 2. So I can put that into my calculator. So I'll open up a fraction. On top, I'll have 8 minus 2. At the bottom, I'll have 3 minus 2. And that gives me 6. So the gradient of line AB is equal to 6. So let us move on to the next part. So example 4, determine the gradient of AB and CD. So it's basically what we've previously done. So let's have a look at that. So we've calculated in the previous example the gradient of AB whereby everything was positive. So I'm not going to do example AB. I'll focus on CD where you have negative values as well, because sometimes it can become tricky to deal with negative values. So we've got C, which has coordinates -5 and 1. We've got D, which has coordinates -1 and 3. So from here, I'm making C my x1 and y1 values. I'm making D my x2 and y2 values. So my formula is gradient equals y2 minus y1 over x2 minus x1. I can substitute. So y2 is going to be 3, y1 is going to be 1. In my denominator area, I've got x2, which is -1, and I've got x1, which is -5. So don't just go and put -5 just because x1 is -5. Keep in mind that you still have to bring down the negative from the formula, then substitute -5. That is important. So my gradient of line CD is therefore going to be, let's see, we can put that onto our calculator. So in my numerator position, I have 3 minus 1. In my denominator position, I have -1 minus -5, and that gives me 1 over 2. So the gradient of CD is 1 over 2. So let us move on. Next, we have parallel gradients. So let's state that the lines AB and CD are parallel to one another. So we'll call the one on the left AB, and we'll call the one on the right CD. If we state that both lines are parallel to one another, it means that they have the same gradient. Keep that in mind. That is extremely important. So the gradient of AB is equal to the gradient of CD because AB is parallel to CD. So let's put in some coordinates for these lines. Let's say that C has coordinates -3 and 1, and D has coordinates, let's make it -2 and -8. So that's our coordinates of C and D. What if the question were to state, calculate the gradient AB? Even though we don't have coordinates for the line AB, we are still able to calculate the gradient AB. The reason being is that because line AB is parallel to line CD, we can then calculate the gradient of line CD, and that will then be equal to the gradient of AB. So let us do that. So we are going to start by calculating the gradient CD. So we have our formula, which is y2 minus y1 over x2 minus x1. From there, we can substitute. So before we substitute, let's label. I'm going to make C my x1 and y1, and I'm going to make D my x2 and y2 values. So we've got y2, which is -8, minus y1, which is +1, all over x2, which is -2, minus, this is x1, which is -3. So we can put this into our calculator. So in our numerator position, we have -8 minus 1. In our denominator position, we have, let's say, -2 minus -3, and that gives us -9. So our gradient of the line CD is -9. Now keep in mind the original question was, what is the gradient of the line AB? So we can say that the gradient of line AB is equal to the gradient of the line CD, which is -9. And the reason is because AB is parallel to CD. That is it. Even though we did not have the coordinates for A and B, we were still able to calculate its gradient based on the property of parallel lines. So it's important to know the properties of the different lines that will assist you in calculating your gradients. So let's move on to collinear gradient. Now, collinear gradients are kind of special because we've got 3 points on one line. So if this represents our point A, if this represents our point B, and if this represents our point C, it then states that if the lines are collinear, the gradient of AB is equal to the gradient of BC is equal to the gradient of AC. Reason being is that these lines are collinear. So all you would then need to do to prove that it's collinear, if you were given the coordinates of A, B, and C, you can then go and calculate the gradient of AB, you can then calculate the gradient of BC, and then calculate the gradient of CD. If all three gradients give you the same value, that means that those 3 points are collinear. So let's say, let's do this. Let's put in some values for A, B, and C. So if we have the line, let's make this line y equals -x plus 2. So we'll give A an x value of -3, and our y value will be 5. So A will then have coordinates -3 and 5. Let's make B 0 and 2. And we'll make C, let's give it a value or an x value of 5. And the y value will therefore be -3. So we now need to prove that these 3 points are collinear. In order for us to prove that they are collinear, we need to calculate the gradients. So we'll start with AB. If we are calculating the gradient AB, we are going to use the coordinates A, which is -3 and 5, and B, which is 0 and 2. So we've got x1, y1, x2, y2. So let us substitute into our formula. y2 minus y1 over x2 minus x1. From there, we can substitute our y2 value as 2, our y1 value as 5, our x2 value as 0, and our x1 value as -3. So we therefore have the gradient of AB as equal to, let's put that into our calculator, 2 minus 5 over 0 minus -3. That gives us -1. So that is the gradient of AB. Let us now calculate the gradient BC. C. So because we're calculating the gradient BC, we'll use the coordinate B, which is 0 and 2. We'll use the coordinate C, which is 5 and negative 3. So I'm going to make B my x1, y1 value. I'm going to make C my x2 and y2 values. From here, I can put in my formula. And substitute. So y2 is negative 3, y1 is positive 2, my x2 value is 5, and my x1 value is 0. So from here, the gradient of BC, once we've put that into our calculator, is going to give us negative 1. So as you can see so far, it is working out to be collinear because we've calculated the gradient of AB, we've calculated the gradient of BC, and they were equal. The only thing that's left is to calculate the gradient of AC. So if I'm calculating the gradient AC, I'm going to use the coordinates A, which is negative 3 and 5, and I'm going to use the coordinate of C, which is 5 and negative 3. So A is going to be x1, y1. C is going to be x2, y2. So let us substitute and calculate the gradient AC. So my formula is M equals y2 minus y1 over x2 minus x1. My y2 value is negative 3. My y1 value is 5. My x2 value is 5 and my y1 value is negative 3. So from here, the gradient of AC, we can put that into our calculator. And that gives us negative 1. So that is therefore proof that A, B, and C are collinear, meaning that all 3 points are on the same line because the gradient of AB is equal to the gradient of BC is equal to the gradient of AC. In certain questions, you'll see they can give you unknowns, the same way we had unknowns in our midpoint. So you can maybe have the X value of A as an unknown or the Y value of C as an unknown, and you are then asked to calculate it. So you'll use the same method. You'd calculate the gradients, equate them, and solve for the unknown. So let's move on to perpendicular gradients. So let's say we've got this line. And let's state that these two lines are perpendicular to one another. Perpendicular means that they meet at an angle of 90 degrees. So we've got AB and CD. Let's say we have the coordinates of C as 3 and 8, the coordinates of D as 5 and 10. Okay. If we are now asked to calculate the gradient AB, how would we now do that? So we calculate that using the properties of perpendicular lines. So that property is the gradient of AB times the gradient of CD is equal to negative 1. That is only if AB is perpendicular to CD. So if the two lines are perpendicular, we can then substitute one of the gradients into the formula in order to obtain the other gradient. So as they've stated in this particular question, they've used the symbol of 90 degrees, which then states, or which then means that AB is therefore perpendicular to CD. So we are going to first calculate the gradient of CD, then substitute it into this formula, and then find the gradient AB. So let's start by calculating the gradient of CD. Because we are calculating the gradient of CD, I'm going to use the point C of 3 and 8 and D of 5 and 10. My x1 value, y1 value, x2 and y2. From there, I can now substitute into my formula. My gradient formula being m equals y2 minus y1 over x2 minus x1. My y2 value, which is 10, minus my y1 value of 8, all over my x2 value of 5 minus my x1 value of 3. So from here, I can conclude that the gradient of CD is therefore equal to, let's put that into our calculator. So on top, we've got 10 minus 8. At the bottom, we've got 5 minus 3, and that gives me a gradient of 1. So my gradient of CD is therefore 1. Let us now use our perpendicular formula to calculate the gradient AB. So the formula is the gradient of AB times the gradient of CD equals -1, because AB is perpendicular to CD. So we've calculated the gradient of CD, that was 1. So we can substitute it in, times 1 equals -1. From here, we can divide both sides by 1, therefore giving us the gradient of AB as -1. If you want to prove it, you can substitute the gradient of AB and the gradient of CD into the original formula. So 1 times -1 will end up giving you -1. So that is the proof that AB is perpendicular to BC. Sorry, yeah, AB is perpendicular to CD, not CB. In an exam, they can ask you to prove that it is perpendicular. If you were to prove that it's perpendicular, you won't use the formula, okay? You only use the formula when you are trying to find the gradient of an unknown line. If this question were rearranged and you were asked to prove that AB is perpendicular to CD, step number 1, you would need to have the coordinates of A, B, C, and D. So you would calculate the gradient of AB, you would calculate the gradient of CD, and then multiply them. If the answer that you got was -1, then you conclude, therefore, AB is perpendicular to CD. If you are being asked to prove, take note that you do not work on the initial assumption that they are perpendicular. You are trying to find out, because you could find that in certain cases they might not be perpendicular. So be careful with that. Don't automatically use the formula. First, find the first line, find the gradient of the second line, multiply them. When multiplied, if you end up with -1, then conclude, therefore, they are perpendicular. So let's see, I think that was our last bit of theory. So let us move on to a past paper question. Something important to take note of when you're dealing with analytical geometry. Know your properties of shapes. In your textbook, there is a chapter or a part in your textbook that deals with the properties of shapes. I would recommend understanding how all those properties of a particular shape. It can help you when you're dealing with exam level questions. If you look at this shape here, this is a kite. So we would then need to know our properties of a kite in order to be able to successfully answer this type of question. Okay, so what I will do is I will share a textbook for grade 10, a grade 10 textbook into the group. Those of you that don't have access to a textbook or whatever the situation is, you can use that textbook to go through the properties of a particular shape. I would recommend memorizing all of them, or if you understand it, that's even better. It's better to understand than to memorize, okay? So that will help you a lot. Okay, so we've got question 3. Show that a triangle ABC with vertices 1 and 1. So that's our first coordinate. Vertices A, which has coordinates 1 and 1, B, which has coordinates 3 and 6, and C, which has coordinates 6 and 3, is an isosceles triangle. So before we even look at that question, let's have a look at our types of triangles. We've got 4 types of triangles. We've got a right-angled triangle, we've got a scalene triangle, an isosceles triangle, and we've got an equilateral triangle. So let's start with the first type. Let's do an equilateral triangle first. So an equilateral triangle will have all 3 sides equal and all 3 angles equal. An equilateral triangle always has all 3 sides or all 3 angles of 60 degrees. The sides can be whatever value, but keep in mind that all 3 will be equal. Now this is an equilateral triangle. Now, our second type of triangle that we'll have a look at is an isosceles triangle. Now, an isosceles triangle only has 2 equal sides and 2 equal angles. So we don't have a lot of space. Let us try to squash this up quickly. So, like I mentioned previously, an isosceles triangle has 2 equal sides, 2 equal angles. So we put 2 strokes indicating that 2 sides, 2 angles are equal. So this angle will be equal to this angle. Whereas an equilateral triangle, all 3 angles are equal. Let's have a look at our third type. Our third type is a scalene triangle. With a scalene triangle, all 3 sides are different. So this side is not the same as this side, which is not the same as this side. So a scalene triangle has 3 different sides, 3 different angles. Keep that in mind. And finally, we've got a right-angled triangle. With a right-angled triangle, just as its namesake is, there is a 90-degree angle. So that is the 4 types of triangles that we have. Now, if we go back to our question states, show that a triangle ABC with vertices A, B, and C is an isosceles triangle. If this is an isosceles triangle, we need to prove that 2 sides are equal, or we can prove that 2 angles are equal, depending on the information that we are given. So because we are given coordinates, we are not going to use the angle approach. We are going to use the side approach. So we need to prove that 2 sides are equal. So let's draw a rough sketch of this triangle. So we've got A, B, and C. A has coordinates 1 and 1, B has coordinates 3 and 6, and C has coordinates 6 and 3. So if you look at the coordinates, keep in mind that as you move in the positive x direction, your x value needs to increase. So if we look at these coordinates, as you can see, my value of A has the x coordinate of 1. My value of B has the x coordinate of 3. So it's not possible for 3 to come before 1. So let us swap A and B. That would be the correct notation of this triangle. So we've got B, or rather A, which has coordinates 1 and 1, and B, which has coordinates 3 and 6. So now if you notice, A comes before B because 1 comes before 3, and C is at the end because it's the biggest x value. 6 is bigger than 3 and 1. So let us now find the lengths of AB, BC, and AC. So we need to have two equal lengths. So let us attempt this question. So we know that our distance formula is D equals the root of x1 minus x2 squared plus y1 minus y2 squared. It doesn't matter whether you say x2 minus x1 or x1 minus x2, it's going to be the same thing. The only thing that you cannot do is have x1 minus x2 and in the y area change it, make it y2 minus y1. If you said 1 minus 2 in the x area, you have to keep it the same and say 1 minus 2 in the y area. So let us calculate AB first. So AB, I'm going to make A my x1 and y1 coordinates and B my x2 and y2 coordinates. So x1, which is 1, minus x2, which is 3, squared, plus y1, which is 1, minus y2, which is 6, squared. Don't forget to complete your root sign. Now, we can put that into our calculator. So we've got 1 minus 3 all squared plus 1 minus 6 all squared, and that gives us the root of 29. So we now know that AB is the root of 29. Let us now calculate BC. So because I've already denoted B as x2, y2, I'll make C x1, y1. So let's see, we've got x1, which is 6, minus x2, which is 3. Keep in mind that I'm using B and C's coordinates, okay? Plus my y1 value, which is 3, minus my y2 value of 6, close the bracket, squared. And once we put that into our calculator, let's have a look at what we get. So we've got the root of 6 minus 3 squared plus 3 minus 6 squared, and that gives us 3 the root of 2. So we know that BC is 3 root 2. So in order for this to be an isosceles triangle, we then need AC to be equal to either 3 root 2 or root 29. AC has to be equal to one of the other sides. So let us calculate AC. I'm going to change my coordinates of C to be x2, y2. Because I don't want to have both y1, y1, x1, x1. So I'm going to make that x2, y2. So this is now going to be y or x1, which is 1 minus x2, which is 6, squared plus y1, which is 1 minus y2, which is 3. Don't forget to square. That is then equal to, so let's put our root sign, and we have 1 minus 6, close the bracket, squared, plus 1 minus 3, close the bracket, squared, and that gives me the root of 29. So this is now the root 29. So as you can see, AB and AC are equal to one another. So we can say AB equals, excuse me, AB equals AC. Therefore, ABC is an isosceles triangle. So we've now proved that triangle ABC with vertices A, B, and C is an isosceles triangle. So a quick recap before we go to the next question. It was important for you to be able to know your 4 different types of triangles. Your equilateral triangles, which has all 3 sides equal, and each angle equal to 60 degrees. Your isosceles triangle, which has two equal sides, two equal angles. Your scalene triangle, which has no equal angles, no equal sides. And finally, your right-angled triangle, which has a 90-degree angle. So let's have a look at question 3.2. In the diagram below, ADCB is a kite with A being 3 and 5 and B -1 and -4. So we are given the coordinates of A and B, and we are told that this is a kite. AD is equal to DC. So AD, where's the AD equals DC. So let us state that they are equal. So we now know that AD equals DC. And then AB equals BC. So we've got AB equals BC. So what is important about a kite? The two top lines are equal to one another. The two bottom lines are equal to one another. Then it states D is a point such that AD is parallel to the x-axis. So we now know that AD is parallel to the x-axis. What that then means is that this is now going to be 90 degrees. If AD is parallel to the x-axis and if DC is parallel to the y-axis, it would then be perpendicular, or it would meet at a 90-degree angle. So let's continue to read our question to see if it actually is. If it's not, we'll come back and erase it. So it states D is a point such that AD is parallel to the x-axis and AD is 5 units. CD is perpendicular to the x-axis. Okay, so because they've stated CD is perpendicular to the x-axis and AD is parallel to the x-axis, that therefore means that AD is perpendicular to DC. So it is in fact 90 degrees. We were then also told that this is 5 units. The diagonals intersect at P. So the diagonals are these lines that are on the inside. They intersect at point P, which then means that based on the properties of a kite, P is now the midpoint of AC, but P is not the midpoint of the longer diagonal. So I'll repeat once more. Based on the properties of a kite, AC has a midpoint at P, but P is not the midpoint of BD. Those are one of your properties of a kite. So we've read the top paragraph. Hopefully everyone should be okay with that information. Let us now move on to question 3.2.1. So we have 3.2.1, show that the coordinates of C are 8 and 0. The student that has your mic unmuted, if you're not asking a question, please mute yourself. Just give me a moment, please.
Well,
Okay, apologies for that disruption. Let us proceed. So we've got question 3.2.1. Show that the coordinates of C are 8 and 0. Let us go back to our diagram to see where is C. Okay, we can see that C is on the right side. C is our point here on the x-axis. That is C. We now need to show that C is going to have coordinates of 8 and 0. So let's see, how would we now show that C is now going to have coordinates 8 and 0? Because it previously mentioned, or because the question previously mentioned, that AD is parallel to the x-axis. That therefore means that AD is a perfectly horizontal line. That then means that the y value of D is going to be the same y value as A. So even though we don't know what the x coordinate of D is, we know the y coordinate. It's going to be 5. It's going to have the same y value as A. Next, because it's stated that DC is perpendicular to AD, which therefore means that DC is parallel to the y-axis. We therefore know that D is directly above C, which means that the x value of D is the same x value as C. And we don't know what the x value of D is, so we can't really say as yet. But what we do know is that because C is on the x-axis, we can therefore give it a y value of 0. So we don't know what the x value is, but we know the y value is 0. So the only thing that we have left to do is calculate the x value of C. So I'll repeat once more. Because AD is parallel to the x-axis, that makes it a perfectly horizontal line. Okay, that is how we were able to find the y value of D. But we don't really need that for now in order to calculate C. What we do need is, or what we do need to know is, what is the x value of D or the x value of C? Because keep in mind, they're going to be the same x value. So how do we do that? If this is a perfectly horizontal line, it means that from here to here is going to be 3 units. So that is 3. Then from A to D, we were told that is 5 units. That means that the x value of D is going to be 8. Because D is directly above C, because DC is a vertical line and is perpendicular to AD, we therefore know that C is going to have an x value of 8. So that is 2 marks. Let us now write it out in order to obtain those 2 marks. So we know that C is on the x-axis, therefore the y value is 0. We then know that AC, let's just have a look, I think it was AD, not AC, yep, it was AD. So we now know that AD is a horizontal line, which then means that the coordinate, or more specifically, the x coordinate of D is the same x value as C. So we can write that out as this: dx equals dc, and we're not sure of what it is as yet, okay? So let's go on. How do we now find the x value of D? Let us go back to our diagram. Because AD is perfectly horizontal, meaning it's a straight line, we know that A is 3 and D is 3 plus 5, which makes D 8. Think about it like this. If you were standing at point A and you walk 5 steps to the right, you'd be at position 8, right? So that's all you need to think of. If you are standing at point 3, which has an x value, sorry, if you are standing at point A, which has an x value of 3, and you walk 5 units to the right, you end up at 8. That is how we know that the x value of C and D is 8. So I'll put it in a diagram representation so you can see. So if this is our x-axis, right? Or let's just make this any random line. And we'll say that this is point A, which has an x value of 3. And we don't know what is the point D. But what we do know is that from A to D is 5 units. It's a distance of 5. If you move from 3, you jump 5 spaces, are you not ending up at 8? So that's the logic behind that question. So you can therefore conclude that the coordinates of C are 8 and 0. That's all you needed to do. So let us move on to the next question, question 3.2.2. Question 3.2.2 states, write down the coordinates of P. So keep in mind what I said earlier. Based on the properties of a kite, we know that P is the midpoint of AC, but P is not the midpoint of BD. Please keep that in mind. So let's make a note. We know that B, or let's write it like this. We know that P, sorry about that. Let's just go back up. We know that P is the midpoint of AC, but it is not the midpoint of BD. So keep that in mind. It's one of the properties of a kite. So hopefully you should go back to your textbook tonight, have a look at all your properties. You've got a square, rectangle, triangle, parallelogram, rhombus, kite. There's so many shapes that you can learn the properties of. It's extremely important when dealing with analytical geometry. If you don't know the properties of your shapes, you are going to struggle. So I recommend going and learning them. So let us do question 3.2.2. So we've got P is the midpoint of AC. So let us now use our coordinates of A and C to calculate that midpoint P. So our coordinates of A, let us have a look. What was our coordinates of A? Our coordinates of A were 3 and 5, and our coordinates of C are 8 and 0. So A has coordinates x1, y1, C has coordinates x2, y2. So from here, we can use our midpoint formula. So instead of using M, I'm now going to use P. So x1 plus x2 all over 2, y1, just give me a second to erase that. So y1 plus y2 all over 2, and let's substitute. So P, our x1 value of A, or our x1 value is 3. Our x2 value is 8. That is all over 2. Our y1 value is 5, and our y2 value is 0. That is all over 2. So we can therefore conclude that the coordinates of P are 3 plus 8 gives us 11 over 2, and 5 plus 0 gives us 5 over 2. So those are the coordinates of P, 11 over 2 and 5 over 2. If you want to write it as a decimal, you are welcome to do so. So if you wanted to write it as a decimal, your coordinates would be P, open a bracket, 5,5, semicolon, 2,5. Okay, so let us try to read question 3.2.3. Question 3.2.3, calculate the gradient of line BD. So let us go and have a look at what is the line BD. So BD, we have the coordinates of B, it's given in the question. The coordinates of D, we previously calculated it based on our analysis when calculating or when determining the coordinates of C. So we know that B has coordinates -1 and -4, and D has coordinates 8 and 5. So let us see, we need to calculate the coordinates BD. Let's attempt that. Or not coordinates, we need to calculate the gradient BD. So we previously did a few examples on gradient. So we know that our gradient formula is M equals y2 minus y1 over x2 minus x1. Now, before we actually plug in our coordinates or our points into our gradient formula, let us try to determine our x1, x2, y1, y2 values. So we know that B is -1 and -4. D is 8 and 5. So I'm going to make B my x1, y1 values. I'm going to make D my x2 and y2 values. So when we substitute, y2 is going to be 5 and y1 is going to be -4. My x2 value is going to be 8 and my x1 value is going to be -1. From there, we can have the gradient of BD as equal to, so let's put that into our calculator. We've got 5 minus -4 and we've got 8 minus -1. That gives me +1. So the gradient of BD is therefore +1. So let us now have a look at question 3.2.4. So we've got calculate the length of line AC. So if we are asked to calculate the length, that is the same as calculating distance. So let us look at AC. Where's AC? Okay, so line AC is A, which has coordinates 3 and 5, and C, which has coordinates 8 and 0. So let us now calculate the length of AC. An alternative approach that you can use instead of using your distance formula is to actually use your Pythagoras' theorem, because as you can see, triangle ACD, that is a right-angled triangle. So AC would be known as your hypotenuse. You can calculate AC using Pythagoras. That's an alternative approach that you can use. So let us now use our distance formula to calculate the length AC. And that is question 3.2.4. So we are calculating AC. So our coordinates of A, which is 3 and 5, our coordinates of C, which is 8 and 0. From here, I'm going to make A my x1 and y1 value. I'm going to make C my x2 and y2 value. So my distance formula is D is equal to the square root of x1 minus x2 all squared plus y1 minus y2 squared. Now, because I'm calculating the length AC, I can substitute AC in place of D. Okay. Now, let us try to substitute into our formula. So we've got AC equals the square root of, so x1 is 3 minus x2, which is 8 squared, plus y1, which is 5 minus y2, which is 0, and that is all squared. We can therefore have AC as equal to, so let's put that into our calculator. So we've got open our square root sign, open a bracket, 3 minus 8, close the bracket, squared, plus, open a bracket, 5 plus or 5 minus 0, close the bracket, squared. And that gives me 5 root 2. And you can just put in units because we don't have a designated unit of measurement. That is how we can now calculate the length AC. Okay. Let's have a look at question 3.2.5. So question 3.2.5, calculate the area of the kite ADCB. So we now need to find the area. Let's have a look at our kite ADCB. So ADCB, in order for us to calculate the area of a kite, keep in mind that the area formula is a half times BD times AC. So let's have a look. We need to find BD. We've previously calculated or found the length AC. What I would recommend, apart from knowing your properties of a kite or your properties of shapes, also know your perimeter formulas, your area formulas, your surface area formulas, and your volume formulas. So those are important. When you're dealing with analytical geometry, because most of them are flat two-dimensional shapes, I would recommend knowing perimeter and area. You don't really need to know volume and surface area, but it is advantageous to know them. So what you should know for analytical geometry, you need to know your properties of shapes, you need to know your area formula, and you need to know your perimeter formula. So if we look at this kite, right, we know that our formula is going to be a half times BD, because that's the long diagonal, times the small diagonal, which is CD. If you want a shortcut, just remember cross, a half cross, because your diagonals basically form a cross, right? So a half cross, that's your area of a kite formula. So a half times the big diagonal times the small diagonal. We've already calculated the length AC. All we now need to do is calculate the length BD, and then we can find our area. So let us do that. So we've got question 3.2.5. Your formula for area of a kite is going to be a half times the long diagonal times the short diagonal. So always remember that area of a kite, a half times your long diagonal times your short diagonal. And in this particular case, our long diagonal is BD and our short diagonal is AC. So we already have our coordinates of AC. We only need to find our coordinates BD. Not our coordinates, sorry, our length BD. So let us go and find BD. So we'll use our coordinate of B and our coordinate of D. I think D was 8 and 5. Let us go and have a look at our coordinate of B. So the coordinate of B is -1 and -4. Let us calculate the length now. So our distance formula, which is the square root of x1 minus x2 squared plus y1 minus y2 squared. From here, in place of d, we can substitute bd because we are calculating the length bd. So this is going to be bd equals square root of x1, which is, let us put in our x1 as b, y1 as b, x2 as d, y2 as d. So this now becomes x1 as -1 minus x2 as 8 squared plus our y1 value, which is -4, minus our y2 value of 5. Don't forget that is squared. We can now put this into our calculator. So you'll press square root, open a bracket, -1 minus 8, close the bracket, squared, plus, open a bracket, -4 minus 5, close the bracket, squared. And that is then equal to 9√2. So BD is equal to 9√2 units. So we've got BD and we've previously calculated CD. So let us now substitute this so we can calculate the area of this kite. So our area is then equal to 1/2 times BD, which was 9√2, times AC. What was AC? Let us just go and have a look. Okay, here's AC. Length AC was 5√2. So we've got 5√2. From here, we can put this into our calculator. So therefore, our area is equal to 1/2 times 9√2 times 5√2, and that gives us 45. Don't forget, area is squared. So you'll say units squared. That is therefore your area of your kite, 45 units squared. So I'll zoom out to see if anyone has any questions or anything I need to repeat, re-explain or emphasize on, and then we'll proceed thereafter. Okay, so this is basically everything we've done thus far. We've done question 3.1, 3.2, 0.1, 0.2, 0.3, 0.4, 0.5. In order for you to successfully answer this question, you needed to know your properties of your triangles and your properties of your kites, as well as knowing your distance formula and your gradient formula.